Alright, now we are going to make this geometry application using classes and methods. In the last video I did talk about how you can set this up and use tabs and what name identifiers you need to set these buttons as. This about button is nothing, it's nothing special. Don't try to do anything special for that. It's just a pop-up that shows who made the program. You can do an about button if you want. I just threw that on there in the last video. Hypotenuse, once again, name identifier, make sure you change it. You can change all these, what's it called, these numeric up-downs to a higher maximum value if you want. Their default maximum, well, their maximum right now is set to 10,000. I put it at. I don't know what you're going to put it at. That's your decision. Anyways, go ahead and double click on all these buttons. Basically what our idea is, we're going to take these buttons and we're going to make methods out of them. And the tabs are going to be the classes. The first class will be a circle class. And in it will be two methods for circles, for handling circles and formulas. So the first method will be a get circumference method that basically takes the circumference formula and it inputs the radius and it gets out the circumference. And then you input the radius for get area method and it will output the area of the supposed circle that we have a radius for. Then the triangle class will have a hypotenuse method where you input two known sides and then return the hypotenuse of the supposed 90-degree triangle. And you'll learn a few things along the way. I'm going to be using converting again. I'm not sure if I've used that in a previous video, but we will be converting decimals from one, or what's it called? We will be converting variables from one type to another, so that's pretty cool. And you'll just learn a few other things along the way. So make sure you've clicked on all of the buttons. As you can see, I have a circum button, an area button, and a triangle button. I might as well call that a hypotenuse button, but it was too long to type out. There's no real point to making it, that long. So before we can start putting code in these buttons, we need to create our two classes and our methods. So in order to create a class, you go to Tutorial 7, right-click, Add Class. Name it. We'll do the circle first. So name circle.cs. Now, in our circle.cs, we're going to need using system Windows forms. And this basically allows us to use the form1.cs and its elements that it has. And we're going to need our methods, so let's create those. Our first method is going to be get circumference. So let's do a public static decimal. Remember, numeric up-downs have to be decimals. And also keep in mind that public and static are modifiers. I will be going over those in my last tutorial in this series, so keep posted for that, I suppose. And the decimal is going to be called get circum. And we're going to pass in one variable, which will be decimal radius. Now then, it's pretty simple to get the circumference. It's just 2 times pi times r. However, there is one problem we're going to run into with pi. Pi is a double. It's not a decimal, it is a double. So we're going to have to convert it to a decimal to even be able to multiply it times the radius, because a decimal and a double cannot be multiplied together. So we are going to create a pi variable, which will be a decimal, and we'll set it to convert.toDecimal. That's our conversion function, our method that converts pi to a decimal, or whatever we input to a decimal. And we're going to input math.pi. And there you go. It takes the pi variable and it converts it to a decimal. So now we can multiply it by our radius. So we're going to do a decimal result is equal to 2 times pi times radius. 2 pi r. And then return our result for the user to see. So we've got a method that inputs our radius. It creates a pi variable and converts it to a decimal. Then it multiplies pi by 2 by radius, and then returns the circumference to the user. Now we're going to create our area function. Once again, public static decimal, and it'll be called get area. And also a decimal will be passed through that will be known as radius. And once again, we're going to need to convert pi, because that hasn't changed. Convert dot to decimal math. To be honest, I could have copy and pasted this, but with the very ease of use in the autofill and Microsoft Visual C#, I just don't need to copy and paste things when it's so easy to type them out, you know. Then we create our result, and it's going to be pi r squared. So it's going to be pi times, and then radius times radius, which is essentially squaring it because it's, you know, radius times radius. And then return our result. So we've got our get circumference and our get area methods. Feel free to put on a little comments. I think that's how you spell circumference. Alright, so we have our circle class. We have it, and it's perfectly created. It assumedly works fine. Now it's time to create our triangle class, which will only have one method in it, so it's not that difficult. Add class, and we'll call it triangle. However, our triangle method will be a little more difficult. Keep in mind we also have to add our using system.windows.forms once again. Otherwise, you know, form 1 will not work correctly with it. So now we create our get hypotenuse function. Once again, public static decimal get hypo is what I'm going to call it. I don't want it to be too long, you know. And then we're going to do decimal side 1. This is the a squared side, and then the b squared side will be decimal side 2. Okay, so once again we're going to need our pi variable. I'm just going to go over here to our circle 1, and this time I'm just going to copy it, you know. Just, you know, save us some time. Might as well. Wait, no, we don't need that. Never mind. The get hypotenuse function is going to simply use the Pythagorean theorem. I mean, that's really the best option. You know, that, I mean, you can use, I guess, sine and all that other jazz, but we don't have any angles other than 90 degrees, so let's just use Pythagorean theorem and get the hypotenuse. So it's going to be a squared plus b squared is equal to c squared, and we want c. So it's going to be a squared plus b squared, and then you're going to square the sum of that. So what we do is we say result, or rather decimal result, is equal to side 1 times side 1 plus side 2 plus, or rather times side 2. So that is it, but without being square rooted just yet. However, here's the problem. To use the math square root function, you have to be square rooting a double, and when it comes to, you know, a decimal. So you're going to have to use a double variable. So we need to convert this result to a double. So we're going to say double res underscore dub, and set it equal to convert dot to double, and then inside we're going to give it our result that we currently have. And then the outcome of the square root has to be also a double. So double res, or I guess we can just say res dub is equal to square root. Actually, what we could do is we could just say result is equal to convert dot to double, or to decimal rather, and then take the math dot square root. The square root function basically does exactly what it says it is. SQRT just square roots whatever you give it. So we're going to give it our res dub. And it should work out fine. So basically we just created our result that adds on a squared plus b squared, and then we created a temporary res underscore dub, which is a double, and it converts our result to double. And then over here we square rooted our res double right here, and then converted that square root to a decimal. I guess if we really wanted to, what we could do is we could replace res dub with convert to double result right here, and just kind of, mash it on and just get rid of that whole line. So let's go ahead and do that. I mean, it looks awkward and gaudy, but it works, and it condenses it down to one line. And now we can just return our result, and now we have no errors. There we go. So that is our get hypotenuse, method, and we now have our two classes, our class of circle and our class of triangle. And we are ready to use them in our buttons. So let's start out with circumference. Now then, in order to use these methods, I guess we can just create a result variable, as we usually do. Decimal result is equal to circle dot, we're doing circumference, so get circumference, and then we just take our take our numeric up down, which is circumbutton. No, no, it's not. It's I believe it is. Oh no, it's radius. Radius 1 dot value. That's our numeric up down. And what we do with that is we just output it to the user using our standard message box method that we usually have been doing. The circumference is, and then result. So let's test this out. If we give it a radius of, say, 3 and get the circumference, it's about 18.84955, and so on and so forth. And I think we can agree that that is a legitimate claim. 2 pi r, 3 times 3.14 is about 9, times 2 is 18. So yeah, that's legitimate. That is legitimate. And we can do the same thing for our other buttons. For instance, for area, we can just copy and paste that, change the get circum to get area, use the same radius variable, change circumference to area. Triangle button, change it up a bit, change the circle to triangle. Get hypo, change radius to side 1 dot value. Oh wait, I believe it's try side 1 dot value, and then try side 2 dot value. And as you can see, we get our decimal result, and we can just say the hypotenuse is, and then our result. So let's run it and let's see how our buttons are doing. If we give it a radius of 2, circumference works, area works. Wait, hang on. Get area, radius 1 value. Wait, am I reading that right? do 3. Okay, yeah, okay, it's working. It's just 2 was so close together to the other 2, I didn't know. Yeah, that's right. 2 is the same circumference as the area. That is correct. I forgot about that. All right. For hypotenuse, we can take the known sides and make it like a, I guess, a 3, 4, 5. And the hypotenuse will be 5. If you ever take, calculus, pre-calculus, you'll get very familiar with 3, 4, 5 triangles. It's just something we kind of memorize, I suppose. And you can put something random in there. Hypotenuse is 41, and there you go. It works out fine. Once again, our about. And definitely really cool stuff. We've got our 2 classes. We can feed through to our classes using our awesome new methods that do these calculations for us. And we can. The cool thing is you can use these methods throughout the program. Whether you, it reduces the amount of code. You would normally have to take all of this and do it each time you need to find the circumference or find the, that sort of thing. So it's really neat structural stuff. Whenever you start coding out really long methods, you're going to find the use of this. So I hope you find this very useful, and I hope in the future you find really cool ways to use object-oriented programming. In the next tutorial, I'm going to talk about objects. So objects and instances, it's going to be pretty neat. It's basically creating different instances of our classes. For instance, if you have a class called car, you can create like a Ferrari instance of that class and a DeLorean instance of that class. So really cool stuff. Stay tuned, and I'll signing off.